All right, you little chemistry slackers. Moving on. This will be a quick one. We're just going to go over number 11 from that critical thinking section, calculating the empirical formula. All right, so again, I'm operating under the assumption that you actually care about your progress in chemistry and read where I explain what to do. I'm just going to help you out through the steps. All right, so moving forward. Right, I put together, or I copied and pasted the little example problem down here just so we can point to what it shows you on the ChemQuest as a reference for number 11. So again, we are trying to calculate the empirical formula. So empirical formula, as we mentioned before, is the ratio of one element to another within a compound. All right, and we can figure that out, calculate it based on percent composition. Right, so all we have to know is percent composition of the various elements, and then of course we have to know the mass of those individual elements, atomic mass or molar mass in this case. All right, and the way it looks is first you take the element by itself. So we have nitrogen and hydrogen. So we're going to have N, X, and H, Y. Right, we're trying to figure out how many nitrogens compared to how many hydrogens in this case. Okay, so we have certain percent composition nitrogen and another percent composition hydrogen. We can use the percent composition to figure out what the empirical formula is. And what we do basically is you're going to take the percent over mass. All right, and that's just going to give you a number. And we'll talk about what to do with that number in just a second. So what we have is 82.4% nitrogen, right? So we're going to go 82.4 over the mass of nitrogen, which we know is 14.01. From our periodic table, you could, all right? And so when we do that, we get approximately 5.9, all right? Now, that number is not very meaningful to us yet, but we can kind of talk about what to do with that in just a second. So this is for nitrogen. All right, now we'll do the same thing with hydrogen. We have 17.6% hydrogen over the mass of hydrogen, which is 1.01, right? And then we get approximately 17.4. All right, now what we've done is we've actually created a ratio, but that ratio is sort of an odd numbers, irregular numbers that make it a little bit harder to spot. All right, now those of you with mathy brains could probably pretty quickly figure out that this is a 1-to-3 ratio, right? If you're not so mathy in the brain, you don't spot how I got 1 to 3 there, we can quickly show you how we do that. And the way that would be done is you have your two numbers, right? 5.9 and 17.4 in this case. And all you do is you divide each of these by the lower of the two. So the lowest number is 5.9, right? So to figure out my number for nitrogen, I'm going to go 5.9 over 5.9, which equals 1. All right? So that means in my empirical formula, it's going to be 1 nitrogen, so no subscript, okay, for every X number of hydrogen. So in this case, my number for hydrogen is 17.4. So hydrogen is going to be 17.4 divided by the lower of the two numbers, which is 5.9. Divide that by 5.9, and I get something pretty darn close to 3 in that case. All right? So what this is telling me is I have a 1-to-3 ratio, 1 nitrogen for every 3 hydrogens. So my empirical formula would be NH3. All right, so again, you take the percent of that compound, divide it by the mass, percent composition of the element divided by the mass of the element gives you a number. Do the same thing for the other elements in the compound. Those are the numbers. You divide these numbers by the smallest, right? And that'll get us close to a whole number ratio, 1 to 3 in this case, right? 1 nitrogen for every 3 hydrogens. That is our empirical